Good morning, sir. I'm Incharar Devarika. So I'll be explaining about first law of thermodynamics and cyclic processes. So introduction to first law. It states that energy can neither be created nor be destroyed. It can be only transferred from one state to another, which is nothing but the law of conservation of energy. And we have general form, which is delta Q is equal to delta U plus delta W, where delta Q is nothing but heat supplied to the system and U is internal energy and W is the work done by the system. And based on work done by the system or work done on the system, will change the signs. And first law of thermodynamics, here we have the diagram where this is the state 1 and state 2, where heat is transferred from while state 1 is converting into state 2, and that heat which is transferred is also the work done. So understanding the terms, so heat is energy transfer due to the temperature difference, and W is the work energy transfer due to the force and displacement. Internal energy is nothing but sum of molecular, kinetic and potential energy. System is region which we consider for the study, and the surrounding is everything except the system which is outside the system, and boundary is that system and which separates system and surrounding. And sign conversion is if heat is added to the system then it is positive, if heat is exerted by the system then it is negative, and work done by the system is positive and work done on the system is which we will consider as negative. And in cyclic process means the even though the process goes through series of changes, it will returns to its initial state. That means a cyclic process is one in which the system returns to its initial state after the series of changes. So for example, heat engine, refrigeration cycle, etc. And since the final and the initial states are same, we can consider at delta U as 0, that means internal energy is 0. That since the final state and the initial states are same, it will returns back to its initial state, so delta U will be 0. So so we can derive that from the first law, delta Q is equal to delta U plus delta W. Here since delta U is equal to 0, delta Q will be equals to delta W, which means whatever the heat will supply as input will be getting that as work output. Net heat supplied will be equal to net work done by the system. So that means all the energy entering as heat leaves as work output, and that is used to analyze the efficiency of engines and cycles. So we can say that energy is conserved in cyclic process. That means energy can neither be created nor be destroyed. It will only transfer from one state to another state, and internal energy returns to its original value where delta U will be equal to 0, and heat supplied is converted into work output from that equation, and these are used in engines, turbines and compressors. So we'll see how to represent this in PV diagram. So the area enclosed by the cycle on the PV pressure and volume diagram is the representation of net work done. Whatever the work done, that will be represented in the area enclosed in that enclosed cycle PV diagram. So for clockwise cycle, work done by the system, which is nothing but positive, and anti-clockwise cycle, the work done on the system, and that is negative. And for example, gas expands, work is happening and it's expanding, so it's work done by the system, so it will be positive, and gas compression is work done on the system, so it's negative. And cycle returns to it or initial state, that means total internal energy change is 0. And we can see here in the PV diagram where pressure is taken in y direction and volume is taken in x direction. The A to B, which is represented as x, is nothing but the clockwise cycle and B to A is anti-clockwise cycle, and it's returning back to its initial state A. That means the total internal energy change is nothing but 0. So we will see the numerical examples. So if heat added will taken as Q1, which is 500 kilojoule, and heat rejected is Q2, which is 150 kilojoule, and Qnet is nothing but Q1 minus Q2. We will get it as 350 kilojoules, and Wnet will be also equal to 350 kilojoule. That means Qnet is equal to Wnet from the first law. And for numerical example 2, a question absorbs 200 kilojoule of heat and does 150 kilojoule of work. During the compression, 20 kilojoule of work is done on the gas. Find the net heat and verify the first law. So the gas absorbs 200 kilojoule of heat. That means we'll taken as Q1, and compression 20 kilojoule of work is done, and 180 kilojoules of work done during the absorption. So Wnet will be equal to 150 minus 20, which is nothing but 160 kilojoule. And Q supplied, as I said, 200 kilojoule. Q rejected is 200 minus 160. Wnet will be equal to Qnet. So we can take that value for this, that is 40 kilojoule. That means energy is conserved from the first law. So numerical example 3. So a gas undergoes a cyclic process consisting of isothermal expansion, where temperature is kept constant, a 400 kilojoule heat is absorbed, isochronic cooling, 150 kilojoule heat is rejected, adiabatic compression, where pressure is kept constant, that we have to find. To find the work done during the adiabatic compression, since we know delta U is equal to 0, that means Qnet will be equal to Wnet. Whatever the heat we will supply, that will be equal to work done. So Qnet, from the question we know 400 kilojoule and 150 kilojoule. If we minus, hence Wnet will be also equal to 250 kilojoule. So net energy balance is satisfied. So here are some real life applications: steam power plants, automobile engines, air conditioners and refrigerators, gas turbines. All these operates based on the cyclic thermodynamic principle, meaning that the working fluid goes through a series of process and returns to its original state after each cycle. And in short, almost every energy conversion device, from cars to refrigerators, uses thermodynamic cycles to convert heat into work or vice versa. That's why the thermodynamics is so important in engineering as well as daily life. So the conclusion is, first law, energy conservation principle, and in cyclic processes, delta U will be equal to 0. That means net heat energy supplied as input will be equal to the work done as output. And energy conservation means energy can neither be created nor be destroyed. It can be only transferred from one state to another state. And foundation of all thermal mechanics and power cycles. Reference. Thank you, sir.